Hi everyone, in this video I'll explain variable and data types in C# in the simplest way possible. By the end you will know what a variable is, the main data type categories, how to declare variables, type conversions, and lastly boxing and unboxing. All of these will have a definition followed by small examples in Visual Studio which you can copy. Let's go. First we'll go to the PPT. Yeah, here let me maximize it. Yeah, so first, what is a variable? A variable is a named container that holds a value while the program runs. I'll explain about variable and data types with live example in Visual Studio. Next, moving on to what a data type is. In C#, data types define the type of data a variable can store, such as the integer, floating point numbers, characters, strings, boolean values, etc. Now let's move on to Visual Studio, where I'll demonstrate what a variable and data type is. Yeah, here I have already created a console application. If you don't know how to create a console application, you can refer to the last video in this channel. Yeah, so let's remove this part of code and we'll see how to declare a variable. For example, I'll declare an int variable, int a is equal to 5. Now here, as you can see, a is a variable. Now variable is nothing but a labeled box. Think of it as a labeled box, like where a is the label and 5 is the value that is stored in the box, and what type of data we can store in particular box is defined by the data type. Like if the variable is of int data type, it can store numbers. And then moving on, if the variable, let's say str, is a variable of string data type, then it cannot store numbers. It can store only strings or words. Then next, if I declare a char data type, then it can store only single alphabets, which we can declare using single quotes. Then if you want to declare any floating point numbers, then you can use float data type, float f equals to 25.23 f. And then moving on, if you want to store boolean values like true or false, then you can use bool data type. Yeah, this is how you declare a variable in C#, where a variable has its value and also the type which it can store in the variable. Yeah. Now moving on to different type of data types in C#. Yeah, there are mainly 3 different types of data types in C#. The first one is the value type, which holds the actual value. Second one is the reference type, which holds the reference to an object on the heap. Like value type data types, variables are stored in stack, and reference type are stored in heap. That's why it refers to the object which is stored in the heap for reference type. And then moving on to pointer type, this one we rarely use, but it is nothing but a low level pointer which we use in an unsafe environment. Now let's see first the definition of each, and then we'll continue with the example in Visual Studio. So first one is the value type. So in this particular data type, the values are stored directly, and then common value types are int, long, float, double, decimal, char, bool, and user defined structures. And then when you assign a value type to another variable, you get a copy. Now let's see an example of value type in Visual Studio. I'll remove everything. Yeah. Let's declare an int variable again. Int s equals to 35. Now I have declared one variable of int data type. Now let's declare one more variable of same integer data type, and then assign the s value to the k variable. So once this is done, now let's print it. Sorry, I have declared this same again. Yeah, now let's print it. First we'll print the s value, and then we'll print the k value. Now if I save the program and run it, you can see both s and k have the same 35 value. Now what if I update the k value? Now I will assign k is equals to 48, and now if we print both values again, let me close the console, save the program, run it again. Yeah, now if you see, initially we assigned 35 to s integer and then copied the same to k, so both have the same value, but then we updated the value of k to 48, and in the console you can see it updated only for k variable. It didn't update the s value. This is the case in value types, like if you change one value, it doesn't affect the other variable. Now let's move on to reference type. First we'll go through the definition. Yeah, the reference type. This type of data type stores the value in heap, and it points the object which is present in the heap. So common ones are string, arrays, classes, and delegates. Assigning a reference type to another variable makes both the variables point to the same object. Yeah, let's see an example of this in Visual Studio. I'll remove everything. Yeah, so to create a reference type, first let's create one more class called person, and this person class has one property of string data type called as name. Now let's create an object of person class. You can create it using var variable, where let's say p1 equal to new person bracket. Now let's assign p1 object name to something like Swapnil. Yeah. Now let's create one more object of class person and assign the earlier object p1 to it. Now let's print both the objects. Yeah, let's save the program and run it. Yeah, here as you can see, initially I assigned Swapnil as the value to p1 object, and then I copied the same value to p2 object, so both of them have the same value. Now let's update the value for p2 and check what happens. I'll assign p2 dot name to some different name, let's say Thor. Now if we try to print both values again, let's save the program and run it again. Yeah, now if you see, initially we had Swapnil assigned to P1 object and then copied the same to P2 object, but then here if you see on line number 17, we only updated the P2 object, but in the output you can see the P1 object also got updated. This is because in reference data type, if you create a new object and assign the same value as that of the previous one, and if you update any one of the value, as both of the objects are pointing to the same location, so if you update one, the other one also gets affected. So this is the case with reference type. Now let's move on to the pointer data type. Pointer data type is nothing but a low level pointer like the int, star, etc. Star is nothing but the asterisk used in unsafe code. Like we'll go through this in sometime in Visual Studio. You rarely need them in normal C#. If you do, you must enable the unsafe and compile with /unsafe. So for most applications you will never use this raw pointer. So let's see an example of this in Visual Studio. I'll remove this again. So to make use of the pointer data type, we need to declare it in an unsafe scope. So first we'll say unsafe, and then we'll declare the variable of pointer type. So int x equal to 10, let's say, so that now x is an integer data type which holds the value of 10. Now let's create a pointer data type, int asterisk px. This holds the address of x variable. Like let's suppose now x stores the value 10, but in the memory this will have some location value stored with respect to it. For example, like 0x1122 something. So that value is stored now in px, star px. Now let's try updating the value for it. So star px equal to 20. So now we are updating it through the pointer variable, such that initially the x value had 10, now that it has the value of 20. So let's try to print this to confirm. Yeah, I have saved the program. So before executing it, you can see there is an error mark on line number 8 on unsafe word. This indicates that if you are making use of a pointer data type, you need to not only include this in an unsafe scope, but also enable the unsafe mode. So for that, let's go here on the right side under the Solution Explorer, right click on your project and then go to Properties. Yeah, under the Build section, scroll down, you will see an unsafe code checkbox. So check this box, close it. Now you can see the error mark has gone. Now let's save the program again and then run it. Yeah, now you can see we updated the x value variable with the help of a pointer data type. Yeah, now let's move on to the type conversion. I'll close this and also revert it back to normal mode. Build unsafe. Yeah, let's remove this code as well. Yeah, so now let's jump to the PPT again. Yeah, before going to type conversion, I just wanted to share with you guys the table which has all the data types, names, and then the memory size that they like have in when we declare a particular variable of that particular data type. So what size it holds in the memory, so that is declared here, and then the range, the value that they can hold, like what is the range for the value, so that also is given here. So just take a look of this and then we'll move on to convergence. Yeah, let's move on to convergence. So there are two type convergence in C#. The first one is implicit. So this happens when a smaller data type tries to convert to a bigger one, and here there is no external thing that we need to add, it happens automatically. But when it comes to explicit conversion, which is nothing but when a bigger data type tries to convert to a smaller one. So in this case, let's consider like there is a 5-liter water bottle and there is a 2-liter water bottle. So if you pour all the water from 5-liter to the 2-liter water bottle, there is a chance that the extra 3-liter whatever is there, so that will be wasted, which will not be stored in the 2-liter water bottle. So that is the case in variables as well. Like when a bigger data type tries to convert to a smaller one, there is a probability or there is a chance of losing the data. So let's see an example of both in Visual Studio. Yeah, here I'll declare a int variable of small name and store 5 to it. Now I'll declare a long variable, long data type variable with name big, and then store the and then pass the small variable to it. So this is nothing but implicit conversion. Yeah. Here I'll again show you the table. Like we have the int, which is a smaller type which stores only 4 bytes, and then we have the long which holds 8 bytes. So when we convert from int to long, which is nothing but this from smaller one to bigger one, this is called implicit conversion. Now let's print the value of big variable. Actually we'll print both. Yeah, let's save it and then run. Here as you can see, we had 5 stored in the small variable, and then the same we pass down to the big variable, which has again the same value. So there is no data loss. Now let's see an example of explicit conversion. I'll declare a float variable with name v and store a value of 36.19 f. So whenever you are declaring a float variable, you need to include this f suffix. Yeah. Now let's declare a int variable of name I, and then we'll try assigning the float variable to it. Now as you can see here, we got a error. So this indicates that cannot implicitly convert the float to int. This is because we are trying to convert a bigger data type to a smaller one. If you see the table here, you will see float is a bigger data type. If you see the range that it can hold, and then here is the int, you can see the range that this can hold. So this is like obviously smaller than this one. So when you try to convert from a bigger data type to a smaller one, you need to explicitly cast it out, saying, hey, I am converting from a bigger one to a smaller one, so please adjust. So in this case, what happens in explicit conversion, there is a chance of a data loss. So that we'll see in the example now. So now to convert a bigger data type to a smaller one, like the float to int, we need to explicitly declare here, like consider the v variable as an int and then store the value in the int variable. So now what happens, the float value, which is 36.19, this gets converted to an int value and then that is stored in I. So let's try printing both. Yeah, this is called explicit conversion. Let's try printing them. Yeah, save the program, run it. Yeah, here as you can see, initially we had 36.19 stored in the float variable, but then when we tried converting it to a smaller one with the int variable, you can see there is some data loss, which is the 0.19 value got lost while converting. So this is the case with explicit conversion. Now let's move on to boxing and unboxing. Yeah, boxing and unboxing is nothing but boxing happens when you when a value type is wrapped into an object, like when you pass a value, like convert a value type to a object type. And unboxing is nothing but the unpacking of the object back to its value. And when you are boxing it, it allocates memory and costs performance. So we need to avoid this in hot loops. There is a spelling mistake. I'll update this. Yeah. Now let's see an example of boxing and unboxing in Visual Studio. I'll remove everything. Yeah. Let's declare a variable of int v called and have 1, 2, 3 stored in it. And let's create an object called as boxed, and then we'll store the v into it. Now v is a value type and this is stored, value types are stored in stack, and then boxed variable is a object type, and this is a object type, and they are stored in heap. So here what we are doing, we are sending value type to a object type. So here this is called as boxing where the value is converting from stack to heap. Now let's print it. Print the boxed value. Yeah, save the program. And the green one which you see, these are the comments. These will be ignored by the compiler in C#. So these are like most of the time comments are used for explaining the code or what the particular line does. So that's why we use comments, and these are single line comments. If you want to use multi-line comments, that one we can do it like this, like slash asterisk, and then whatever you enter after this, like this is a, and then multi-line comment, and then while ending again we need to use asterisk slash, so that whatever we add in between these slash asterisk and asterisk slash will turn into a comment. Yeah, let's save and run it. Yeah, here you can see the boxed value has the 123 value which was assigned to v variable. Now let's update the v value again. V is equals to 456, and then let's try printing the values again. We'll print v, and then we'll again print the boxed value. Yeah, here if you see, this v is a value type, so if you update it doesn't affect the another variable. So due to that, in this case, when we updated the v, it only updated the value of v variable, it didn't update the value of boxed one, so it holds still the old value. Now let's unbox the variable. We'll declare a variable called int unboxed, and then we'll unbox the boxed variable value. So here if you see, we'll get an error again, because when we are here, actually we are converting from an object, like we are unwrapping it back to a value one. So here we need to again explicitly say that, hey, this object type is, consider this object type as an int one. So we need to declare it explicitly here outside int, so that it gets converted. Now if we try to print it, let's save the program and run it. Now if you see, I have again converted it back to a value type, which is 1, 2, 3. Now if we try to compare the unboxed value, which is a value type, with the original one, let's see what happens. Console dot right line are v and unboxed equal. Let's see what we get. V is equal unboxed. Let's run it. Yeah, if you see here, we got the value of false, which means v is not equal to unboxed one. This is because if you see in line number 11, we have updated the value to 456. So now v has the value of 456 and unboxed has the same old value of 123. So due to that reason, 456 cannot be equal to 123. Yeah, so this was about the boxing and unboxing, and that's it for today's video. I hope you learned something new today. Please do like, subscribe and share this video with your friends and family. Thank you.